Data visualization tools are required to translate the findings of data scientists into charts, graphs, and pictures. Understanding how to utilize these tools and display data is necessary for a data scientist to communicate with people in other domains. In this episode, Srini Kadamati hosts a discussion with Jake VanderPlas about the Python ecosystem for data science and the different attempts at creating a data visualization library. Jake VanderPlas is the Director of Research for Physical Sciences at the University of Washington's eScience Institute, where he also received his PhD in Astronomy. In addition to contributing to many Python data science libraries like scikit-learn, scipy, and numpy, and Matplotlib, he's written multiple books that have been published by O'Reilly, and he's given many talks on data science tools and techniques. He's also the co-creator of the Altair project, which is a declarative data visualization library for Python. I hope you like this episode. Dice helps you easily manage your tech career by offering a wide range of job opportunities and tools to help you advance your career. Visit Dice and support Software Engineering Daily at dice.com/sedaily and check out the new Dice Careers mobile app. This user-friendly app gives you access to new opportunities in new ways. Not only can you browse thousands of tech jobs, but you can now discover what your skills are worth with the Dice Careers Market Value Calculator. If you're wondering what's next, Dice's brand new career pathing tool helps you understand which roles you can transition to based on your job title, location, and skill set. Dice even identifies gaps in your experience and suggests the skills that you'll need to make a switch. Don't just look for a job. Manage your tech career with Dice. Visit the App Store and download the Dice Careers app on Android or iOS. To learn more and support Software Engineering Daily, go to dice.com/sedaily. Thanks to Dice for being a new sponsor of Software Engineering Daily. We really appreciate it.
So to start our discussion, let's talk a little bit about Python and its role in the data science ecosystem. A few years ago, you published a blog post called Why Python is the Last Language You'll Have to Learn, where you discuss how reading about the history of the ecosystem made you realize that Python, for most people, was replacing some existing scientific computing tool. Before Python, what was the workflow of a researcher or a data scientist?
Yeah, so that's a good, interesting question, and to be honest, I can't answer it from a personal standpoint because I've never used anything but Python in research. But I went over this a little bit in my scipy keynote a couple of years ago where I went through the history of this. And it seems like in the scientific world where I am, the pre-Python workflow was kind of a hodgepodge of MATLAB, GNU-plot, maybe running some Fortran scripts to do kind of intensive computing on things. And it was really like you needed to have a familiarity with a half a dozen different tools to do different parts of the workflow. And my impression is where Python came into that is it came in as kind of a glue language more than anything. Guido, the creator of Python, has talked about how Python was initially invented as a teaching language, but also as kind of a replacement for the bash shell. Because what scientists and people were doing was writing these bash scripts that would string together all these different tools and different languages and different platforms and moving data around that way. And Python is kind of started out as providing that glue. And if you look at the early scientific Python packages, the numpy and scipy, numpy came from numarray and there's all these different packages that start with num that were the precursors to numpy. But basically the idea there is that the scipy started out as a set of wrappers of Fortran libraries that were well known at the time in Netlib. Things like LawPack and BLAST for linear algebra, things like FFTPack for signal analysis, QuadPack for integration. And if you look at the core of scipy, that's what it is. It's just a set of Python wrappers for these Fortran libraries. And Then, you build on top of that like Matplotlib, which is sort of like a MATLAB replacement that works well with scipy. And the ecosystem just progressed, and pretty soon Python was not only gluing together these old tools, these Fortran libraries and these MATLAB APIs, but also starting to develop its own new set of tools. And along the way, you see things like the scikits being developed, scikit-learn, scikit-image, some of these other projects, and also stuff like Pandas. Pandas is this entirely new thing that was built in Python, not wrapping any existing library, but it sort of showed that Python had come into its own as a platform for data-intensive computing.
Right. No, that seems to make a lot of sense. Because I think historically people kind of have always talked about Python being slow and whatever, but it seems like you have these like core set of low level libraries and languages that have kind of been implemented, and seems like they're battle tested pretty well. And it seems like Python's like a great way on top where people can come in and be very productive and know that the underlying structure is really strong.
Yeah, absolutely, and that's the key when people talk about Python being slow. And it's for scientists or data crunchers that doesn't really matter, because the heavy lifting is all being done by these wrapped libraries and these compiled things. Python is this glue, this convenient glue on top.
Right, that makes sense. So you also mentioned in that same post that you're bullish on Python also because of the Julia language. Could you talk a little bit about the Julia language and why you think that it's really interesting and impressive?
Yeah, so Julia is really cool because it basically tries to create, like if you wanted to create a scientific or a numerical computing language from the ground up, knowing what we know today, it tries to do that. And I really, really like the Julia project because the thing it does is it unifies this glue layer and this computing layer. So you can think about it like the Python library, the user-facing API is Python, but everything under the hood is implemented in C, even in core Python. C Python is implemented in C. Now there are projects like PyPy that try to change this and stuff. But the nice thing about Julia is that the core fast numeric operations are actually implemented in Julia. So there's not this barrier between the user-facing code and the implementation code. And they've done some really nice things. Like they have a really nicely developed type system that works very well for particularly like high performance numerical computing folks. And they have this multiple dispatch model that means that you can basically optimize implementations of functions based on what the inputs are. So best example of this is, let's say you want to do a matrix, solve a system of equations with a matrix. That depending on the type of matrix, you can dispatch to a different underlying implementation. So if you have a dense matrix versus a sparse matrix versus a diagonal matrix, you can specialize those implementations. And then multiple dispatches, I think, are really, really powerful abstraction for this type of computing. And so I'm pretty excited about Julia in general as a scientific computing platform.
So it seems like Julia is very interesting by itself. So what makes Julia compelling for Python? It seems like it's almost trying to replace it in many ways.
Yeah, it's trying to replace it in many ways, but one of the interesting things is that Python's strength right now is the diversity of tools in the ecosystem. Whatever field you're in, if you want to do something in Python, someone has probably already written the package for you, and it's probably out there. So Julia doesn't have that, so they need to bootstrap that somehow, and the way that they're bootstrapping that is by creating really seamless ways of interacting with Python from Julia. So it's almost like becoming this super language where you have Julia and Python, and you can think about it as like Julia is wrapping the old Python libraries the same way that Python wraps the old Fortran. So it becomes all part of one massive ecosystem. So I don't think Python's going to be going away anytime soon, even if people start moving to implementing more stuff in Julia. That being said, I do enjoy writing Python a lot more than writing Julia. There's some pieces to it that just don't feel as intuitive to me. But that also could be just familiarity.
So it seems like the way forward for both Python and Julia is kind of for the people in the Python community to continue building really great packages like Pandas and scikit-learn and Matplotlib, and for Julia to call those libraries and implement them well, or just call them rather, and then implement some of the functionality that Python didn't have great libraries for in native Julia.
Yeah, I think so, and I think moving forward as Julia comes more into maturity, I think that people will end up working on the other way too, like the ability to call Julia packages from Python. The nice thing is the Julia core array model basically maps one-to-one onto the NumPy core array model. So sharing data, sharing memory between a Julia process and a Python process is pretty straightforward. But overall, I think it shows kind of the overall trend in scientific computing. I think is for having less this tool versus that tool, and more having multiple tools work together. And you see this in the IPython project rebranding as Jupyter, which is this amalgamation of Julia, Python, and R. And the vision there is that the Jupyter notebook would be a place where you're not just coding in Python or just coding in Julia or just R, but an environment where you can have all of those interact.
That makes sense. So how would you imagine that workflow being, where you're using Julia for some things, Python for some things, and R for others? It seems like almost like the one great thing about Python was was acting as that great glue layer, and you kind of mostly just worked there. So does this feel like a step backwards, or is just kind of like an intermediate phase?
Yeah, I think it's kind of an intermediate phase. I mean, if you on the user end, maybe things might not change, but when I'm implementing libraries in Python, I often am stepping into C to implement pieces of those and then wrapping it in Python. So like the library developers are already doing a lot of language hopping as it is. So if we start implementing the core of some Python libraries in Julia or that sort of thing, I don't think it'll change the status quo much for Python, but it ends up giving end users more options, I think.
That makes sense. Cool. Let's actually switch gears a little bit and focus on the data visualization. So what, as part of the regular data scientist or researcher's workflow, where exactly does data visualization fit in?
So I see two distinct areas of data visualization. One is kind of your exploratory data analysis. You're just getting a rough idea of what your data looks like. And in that case, you need kind of intuitive, declarative, fast tools that sort of make the hard choices for you in displaying the visualization. And then the other side of it is especially for scientists, is the publication visualizations. And at that point, you need a lot more fine control over what's going on in your plot. And so these two distinct areas are kind of it's hard to have one tool fit them both. So Matplotlib, for example, is very powerful. You can make virtually any visualization you want in it, but it's not particularly good for data exploration because you have to do a lot of things manually. So the manual control that gives you the power to create any figure is what blocks you from doing kind of effective iterative data exploration in Matplotlib. Then you have those are kind of the two areas of visualization that I see, and do you have something to follow up on that?
Yeah, so it's interesting you say that because I've actually worked a lot with Matplotlib, and I definitely agree that while you can basically make any plot you want, it also feels really complex for even some of the basic things. It's also hard to make plots look really nice sometimes. So why do you think that is? Is there something about kind of Matplotlib and the architecture of it which is kind of is it like a leftover from the MATLAB days? Is it like the need to be able to create absolutely any visualization from scratch? Like, why do you think it is as complex as it is?
I think it's because it's a procedural plotting language, and it grew out of MATLAB and out of GNU Plot and some of those tools that were around in the 80s and 90s. And so when I say it's procedural, I mean that you're kind of like you're telling the computer exactly what you want to happen. You say, I want to plot these points, and then I want this text on the x-axis and this text on the y-axis. I want these limits on x and these limits on y. And so by the time you've created a labeled scatter plot, you've done a few dozen lines of code, right? So where visualization has moved in the last decade or two, I think, is more towards a declarative approach, where you think about you're not telling the computer exactly how to do something. You're telling the computer what you want the result to be. And a good example of this is the ggplot and ggplot2 in R. This idea of plotting based on a grammar of graphics, where you have a grammar talking about certain operations or visual structures that you want to happen, and basically the computer figures out how to put your data into that. And the nice thing about that is that you can iterate and you can explore data really quickly. And ggplot has a nice feature on top of that the people who built the library in R have put a lot of thought into making the plots beautiful and using good style defaults. And Matplotlib is still sort of mired in MATLAB circa 1999. Although I should say the Matplotlib 2.0 release is coming out soon, and it has the style defaults completely revamped, and it's getting a little bit better.
Saji is an end-to-end data platform that lets you focus on deriving business value from data. With Saji Present, you can turn your data into a story, easily sharing a presentation from your data lake. Explore data and drill down into details, creating rich visualizations. With Saji Manager, you can easily build data pipelines of jobs mixing Spark, R, Python, and more. Saji is great for predictive analytics, whether you're predicting the failure of a machine in your factory or predicting which sales leads will be the most valuable. Saji helps you take control of your wide variety of data sources and gets them in one place. Check it out at saji.com. SAAGIE.com. Thanks to Saji for being a sponsor of Software Engineering Daily.
So why do you think there hasn't been like a really popular declarative library in Python? Because it seems like R had one that was pretty compelling, that was pretty popular.
Yeah, that's a good question. I think part of it is just the inertia of Matplotlib being the solution for 10 years. Once you have something that everyone knows how to use, and all the code is there, and it's hard to change tools. Now there's been some interesting developments with Matplotlib with kind of APIs being built around it. You have probably the most popular one is the Seaborn library, which is basically a Python library that does some of the, it's not totally declarative, but it allows you to create nice plots, and it builds in some better style choices, and makes a lot of those hard decisions in the background for you, like setting axis limits and axis labels and things like that. There's another one, Yhat has this ggplot interface to Matplotlib that's pretty interesting too. It sort of takes a lot of the things that people like about R's ggplot and implements them in Python with a Matplotlib backend. So stuff is coming along, and I think I think we're getting there, but it's just it's the inertia of having a decade worth of Matplotlib code and Matplotlib knowledge in everyone's head.
So it seems like I've used Seaborn myself, and I'm generally pretty happy with how it's implemented and even the interface for it. I haven't used ggplot, but it seems like both of these libraries could possibly kind of fill the exploratory data visualization aspect of the workflow. Do you think there's what do you think is missing and in those libraries? And do you also see a challenge when you're kind of spending a lot of your time exploring data, and then when you actually want to kind of create something that's publication or presentation ready, don't you think there's kind of some inertia with kind of recoding the whole thing in Matplotlib or another kind of more procedural language?
Yeah, absolutely. So I really think the way forward is to have this is something like what Seaborn is doing. You can do these quick, almost declarative visual explorations of data, but then what comes out is a figure object, and that figure is a Matplotlib figure. So then if you want to start tweaking fonts and tweaking axis sizes and things like that, you can take the output of Seaborn and start using all the powerful tools that Matplotlib has to make it look how you want. So I think that's a really nice model. But then you run into problems with that. Like, for example, Matplotlib it's really nice publishing PNGs or PDFs, but if you want anything interactive or online, it doesn't really have an output for that. So I think that in the end, I guess overall what I'd like to see is some really clean API for data exploration that outputs some sort of unit or figure or object that can then be tweaked in a lower level language to produce the kind of publication quality plots we want. And it would be a bonus if it can also output in like something that's interactive for the web.
No, that makes sense, and that's actually a great transition point, because I'm curious, how Matplotlib is with working with when creating and working with interactive visualization. It seems like there's some functionality, and it seems like along with Jupyter Notebook, you can also kind of create these widgets. That's something I've definitely done in the past, but it also seems limited in many ways. What do you think are the challenges with creating kind of interactive visualizations in Matplotlib?
Yeah, so Matplotlib, the interactions that are built in with Matplotlib are kind of OS system specific things. So, like if you're on a Mac, you have your OS X Windows Manager, Graphics Manager, and Matplotlib knows how to tie into that and let you do things like click and drag and do interactive graphics. But it's operating system specific, and behaviors change a little bit between there and Windows or Linux or whatever graphics backend you decide to use. So Matplotlib has done a phenomenal job trying to abstract away all that system stuff and let you have a single interface to that. But in the end, you're still dependent on a CPU graphics manager, an operating system graphics manager. And what a lot of people are wanting to do these days is, take your data and publish it on a web page, and then, interact via JavaScript or via those sorts of things. So that was not really a thing when Matplotlib was first created, circa 2001, 2002. People weren't, there was no D3, and there was, JavaScript was harder to work with back then than it is now. So there's been a little bit of progress on that. A couple of years ago, I created this MPL D3 package that basically the idea of that is that, the Matplotlib spits out a figure that has all the information about the plot in it, including what the axes are, what the data is, what the mappings between various things. So what MPLD3 does is it crawls the Matplotlib figure, pulls out all the relevant data, and then creates basically an HTML and JavaScript view of the figure. And it works pretty well for about 90% of what Matplotlib does, but that last 10% is the really hard thing to do well. So I think that was an interesting step in the right direction, but I don't think MPLD3 is really the long-term solution, because it's it started out as a hack and then turned into a really gigantic hack.
So yeah, I mean that's interesting. I mean, so how does that workflow look like? Is it you're kind of creating and exporting HTML and JavaScript? So then do you go and edit that JavaScript separately as kind of a separate workflow, or is it is there some way to express in Python code itself what kind of JavaScript objects you want?
Yeah, so the way it actually works is it extracts all the data from the figure and all the relationships, and then spits out this JSON structure that encodes all of that. And then MPLD3 has a JavaScript library that knows how to read that JSON structure and display it. So the problem with it is it's really, really hard to do anything beyond the bare minimum, just because of the way that I constructed it. I think it could have been done in a lot better way, but at the time I was just trying to get something working. But MPLD3 does offer some Python side plugins where you can write a couple lines of appropriate JavaScript code and then add different types of interactivity to the plot. It's not super well documented, and to be honest, I don't think it ever will be. I'm not planning on putting more work into MPLD3 in the future. But I think it was an interesting experiment.
Yeah, it seems like it. So what have you worked much with the Bocal library? It seems like that's a project by Continuum, and they're also trying to kind of bridge the Python and JavaScript cell barrier, if you will.
Yeah, Bocal is awesome. I think they really landed on the right model, which is they have a JSON specification for their graphic, and then they have a JavaScript library that renders and views that, and they have ways of talking about interactivity and things like this. I'm not totally fond of the Python side API for Bocal, but again, it might just be because I'm not super familiar with it. But yeah, they're doing a lot of good things. Another library that's doing similar things is Plotly. And so they also have this Python API that outputs a JSON structure and then a JavaScript library that visualizes it. And they have ways to put interactions in there and to talk about various things. So Plotly is an interesting one too.
So what do you think are like the limitations of this approach? Kind of like, it seems like it's somewhat declarative. You're writing Python code and it's creating, hopefully you kind of just express it in the way you want the plot to look like. And because it's in Python and you're not really kind of writing the JavaScript code, but how does what do you think are the limitations of it? Like, do you think you can actually create really rich interactive visualizations, or is it more about taking a plot you create in Python and then converting a JavaScript and then having a general set of kind of interactivity, zooming and panning that anyone can use?
You mean for MPLD3 or for these?
For Plotly and for Bocal.
So the one of the big limitations of Bocal is that you can't output in vector graphic format. So for example, I can't use Bocal for my scientific visualizations because the journals that I publish to might not take PNG figures. They want EPS or PDF. But that's one problem with Bocal, and that's just because it's really hard to create a system that can do both interactive online visualization and also can output in all these formats. This is one thing I should have mentioned earlier about Matplotlib. One huge strength of Matplotlib is that they have backends for everything, and they're bulletproof and they work well. So if you want to output PNG or JPEG or PDF or EPS or any of those formats.
They do SVG too, correct?
Yeah, and SVG. There's an output format for virtually everything in Matplotlib, and they've been used for 10 years, so they're really well tested.
Makes sense. So let's switch gears a little bit and talk about a project you're working on right now called Altair, which seems like you want to kind of take over this declarative visualization and exploratory side of data visualization. So talk a little bit about Altair and what it's exciting about it for you.
Okay, so to talk about Altair, I want to step back a little bit because a lot of people out here have heard of D3 now, right? Because D3 is this, it basically drives interactive web visualization. It's anytime you go to the New York Times and they have some interactive journalistic article, it's D3 that's driving that. And that's partly because the graphics I guess, graphics editor there is the guy who created D3.
Mike Bostock, right? Yeah.
But yeah, so D3 is great, but if you've ever tried to use D3, it's it takes hundreds of lines of code to create a histogram, right? So you're not going to be using D3 directly unless you're Mike Bostock or one of the power users. So the group that created D3, Mike Bostock's PhD advisor is a guy named Jeff Hare. He was at Stanford and is now at UW, just down the road from me, which is pretty nice. And Jeff and his group created this project called Vega. And what Vega is it's a declarative grammar of graphics, essentially, that is built kind of on top of D3 and what they did with D3, where you can specify a JSON object structure that tells you what your plot will look like, and then there's a JavaScript library that renders it. So this is starting to sound familiar, right? Bocal, MPL, D3, and Plotly. But the difference with Vega, the thing I really like about it is that unlike these other libraries, I think they've drawn on years worth of theory about how graphics are expressed to decide how to express those graphics in Vega. So it turns out to be a really, really nice grammar for specifying graphics. But still, Vega itself is, if you want to create that same histogram, instead of writing 200 lines of D3 code, you're now writing a JSON structure with 100 entries and very specific keys. So that's not super useful for exploratory data analysis, but it is getting to that declarative side of things. So then once Vega was mature, they said, we need something that's a little lighter than this. So we hit Vega-Lite, right? So if you're keeping track, Vega-Lite compiles down to Vega, which compiles down to basically HTML and D3 JavaScript type stuff and visualizes your plot. So Vega-Lite doesn't have all the expressivity of Vega. It makes a lot more choices for you, but it allows you now with a data set to create something like a histogram in, say, 6 JSON entries. Right, so that's something that you can start wrapping your mind around as a user doing exploratory data. So this is where Altair was born. So Brian Granger and I took a look at this Vega-Lite, and it looks like it's really nice and it's very expressive and very powerful. But I don't want to write raw JSON strings, right? I want to write Python code. So we started to brainstorm about how we might create a Python library that would output this Vega-Lite JSON specification. And what we came up with was Altair, and it's gone through a few different iterations. But what it is now is something that I really like this aspect of it. The library, probably 95% of the library itself is auto-generated from the Vega-Lite schema.
Oh, interesting.
So the Vega-Lite schema defines what these JSON structures, what are valid JSON structures that can be passed into Vega-Lite and visualized. So what Altair does is we created tools that crawl through that schema and create Python objects that mirror each of the categories of objects in that schema. And then, so the raw way of using Altair is just to basically create these JSON dicts by building up Python structures. And the nice thing about the Python objects is if you're in the Jupyter Notebook environment, you have tab completion, you have help tools, and it makes it much easier to remember what exactly you're allowed to do within those objects. And it gives you a syntax error if you're violating the JSON schema. So that's nice. You get this immediate feedback. And then on top of that, we've created some sort of syntactic add-ons that maintain this declarative way of thinking about visualizations, but make it a little more convenient to use than just doing a nested hierarchy of Python objects. And so the result is this Altair API that's it's pretty fun to work with. It's still young. We have a lot of work to do on it, but I've found it in using it to in playing with it to explore data sets, I found it to be really intuitive. And the core idea is that if you have some data set and you want, what you do is you map different columns in your data set to visual attributes on the plot. So, for example, first example on the web page is this cars data set. So you say, I want the x-axis to be miles per gallon, I want the y-axis to be acceleration, and I want the color to be the country of origin. So literally, you just specify the data and those three mappings.
Quite declarative.
Yeah, and the plot is created for you. So, and you don't have to worry about axis limits. You don't have to worry about creating figure bounds and color bars and legends, and you don't have to worry about your legend overlapping some relevant part of the data and all this stuff that comes up. So that's the declarative aspect of it.
Continuous integration gives you faster, safer software delivery. With a continuous integration tool like Snap CI from ThoughtWorks, the members of your team can push changes independently of each other, and they can all see their new builds running against different phases of tests before those changes make their way into production. The fastest moving companies that I've talked to on Software Engineering Daily are all using continuous integration. Snap CI from ThoughtWorks is available to anyone. And if you go to snap.ci/Software Engineering Daily, you can check it out for yourself and support Software Engineering Daily. With just a few clicks, I had my own continuous integration set up for some projects that were just sitting in my GitHub account without continuous integration. I got continuous integration up quite easily using Snap CI. If you want to be that hero at your company that starts moving your organization towards deploying often, more confidently, towards that DevOps dream, start working with Snap CI at snap.ci/Software Engineering Daily. Your coworkers will see you working with Snap CI, and they will fall in love with it themselves. Oftentimes, it takes somebody at a bigger company to go out on their own and say, okay, I'm going to roll out CI even though nobody else at the company is using it. And maybe that hero at the company is going to be you. So check out snap.ci/Software Engineering Daily. And thanks to ThoughtWorks for being a continued sponsor of Software Engineering Daily. It really means a lot.
So then if you do run into any problems or if there's anything you want to customize, what kind of capability is there for if you do want more fine-grained control over your plots?
Yeah, so the Vega-Lite grammar itself actually has a lot of customization and configuration in it. So if you want to dig in and change the look of the default output, there's lots of different things. You can specify different colors, you can specify shapes of points, size of your axis limits. You can filter and transform your data in various ways. So Vega-Lite has a degree of customization built into it. But the thing we're really excited about eventually is thinking about this Vega-Lite grammar, this kind of JSON clump of data and metadata, as a way of communicating between different plot libraries. And this is sort of a little more long-term, but what I'd really like to see happen is I'd like to see a tool built where Matplotlib can, a Python tool that can read in these JSON specifications and output an appropriate Matplotlib figure. Because then what you're thinking about is you could do your exploratory visualization in Vega, in Altair and Vega-Lite. If you want some interactive plot, you get that for free. And if you want to tweak the plot and do something a little more for visualization or for publication, then you can output to Matplotlib, start doing Matplotlib's tweaks on it, and you end up with something like that. And there's no reason it should be limited to Matplotlib too, right? Because you could imagine creating a Bocal converter or a Plotly converter. And actually, the authors of those libraries are excited about Vega-Lite or Vega in this context. So it'll be a lot of work, but I really see not Altair itself, but I see Vega-Lite and Vega as sort of a lingua franca of statistical visualization. The same way we were talking about earlier with Julia and Python interacting, and now you're at the point where you don't really have to choose what tool you want. I'd love to see this Vega and Vega-Lite as a way of interacting between different graphics libraries.
Yeah, definitely. I mean, that portable kind of JSON structures is especially interesting, and it seems really similar to the efforts now to unify the data frames. So like Apache Arrow, I believe Dask, and I mean obviously Pandas itself uses ND arrays. So it seems like in kind of the computing side of data science, if you will, that kind of 2D array was the unifying structure that a lot of them ended up sharing, and are now hopefully there's kind of some unification of that. So is that, I'm guessing it seems like you envision something similar for the data visualization tools.
Yeah. You know, the funny thing about that was where Altair was born was at this little this meetup in Berkeley that was the express purpose of the meetup in Berkeley was to start talking about cross-platform and cross-language data frames. And so there were some people that were working on that, but Brian and I gathered in the back corner and brought another couple of people, and we started thinking about cross-platform graphics instead. So yeah, I think it's all related. There's some real challenges in sharing data frames between systems because numerical data buffers are pretty uniform across languages and platforms. Strings are definitely not uniform across different languages and platforms, and data frames really are closely tied to string labels for columns and string data, so it can be tough. Although, Hadley Wickham and Wes McKinney came out with this cross-platform storage format for data frames. Is it Feather? Is that what it's called?
Yeah, I think it's Feather. Yeah.
Yeah. So that's something that's going kind of in the right direction. Yeah, it'll be interesting to see what comes out of those sorts of discussions.
So what other parts of a data science workflow do you see this fragmentation of tools do you think could benefit from some kind of unifying either framework or data structure?
Yeah, it's a good question. It's beyond kind of the data array, the data frame, and the visualization specification. It's hard. I don't know if there's much more that would be practical. The Jupyter Notebook and the Jupyter Lab project that's going to grow out of it is an interesting one because I think it has promise to be sort of a cross-language development environment and computing environment for data science. I'm really excited about Jupyter Lab, what's coming. This is kind of the next generation of the Jupyter Notebook. They're, I think, about 6 months out from first release. And I really think that's gonna change things for the better in the Python world, and then also be useful in Julia and R and other worlds as well.
Yeah, it seems like that's one thing that I think a lot of data scientists have complained about. I think Jeff Hammerbacher in a Quora post said that one thing he wished there was kind of this R Studio for Python, or just kind of unifying IDE in general. And so, like, what kind of features and tools in Jupyter Lab make that really compelling as an IDE for data science?
The most compelling thing is the extensibility. So they currently right now you have the notebook, which is basically a web front end that has the abstractions to communicate with the kernel. And that kernel can be Python, or it can be R or Julia, people who have done Scala and things like that. So what Jupyter Lab does is it takes that kind of hacked together interface between the web notebook and the backend kernel and makes it more well-defined so that you can start to build different interfaces on top. And so at a kind of somewhat trivial but really interesting example is that, let's say you have a markdown file on your file system. You can point two different web interfaces at that markdown file that sit right next to it, one another. One of them will render it as a editable text document, and the other will render it as a rendered markdown. So you can sit there and type. And this is something that can be done in a few lines of code to specify the extension.
That's really cool.
This past summer, when Jupyter Lab was demoed and announced, at one of the hack days, someone from the astronomy community wrote an astronomical image viewer for Jupyter Lab, and it was like, it took a while to figure out exactly what to do, but in the end, it was a few dozen lines of code to create this interactive image viewer for the typical file format that astronomers use. And so I see that sort of thing being really powerful, especially when you can start plugging all these tools together and working with them in one IDE. But yeah, the most users, I think, will use JupyterLab as like a terminal, a notebook, and a text editor all in one place that are all talking to the same Python kernel and interacting.
That's really quite compelling. Interesting. So to kind of start to wrap this up, in this episode we talked about newer languages like Julia. We talked about Python. We talked about visualization libraries. What else is kind of changing in the world of data science that's really exciting for you, and that you think in the next few years is going to be huge game changers?
So one thing recently that's pretty exciting is the advent of all these open deep learning libraries. Things like TensorFlow and Keras and Theano sort of modifying itself to get into that deep learning or neural net space. I think that's going to be really huge, and I'm seeing more and more on the academic side. I'm seeing more and more people getting into publishing their code, being out in the open, and that's going to be huge if we can continue on that track.
Interesting. Yeah, I mean, definitely. I mean, like, I think Vega is a clear example of this, right? Like, that seems like something that came out of academia, but is now kind of being used a lot in industry, especially for these open source libraries. Is that something you want to encourage a lot more of, like collaboration between academia and the data science industry more generally?
Yeah, that's I don't know necessarily academia and industry in particular, but I think what I want to encourage, I would say, I want academia to release the tools that it's creating for research. And if that ends up being something that people in industry want to use, then that's great. If it ends up being a tool that other academics use to push knowledge in their own field, then that's great as well. So, I'm at the eScience Institute at University of Washington, and this is we're in the middle of a 5-year data science initiative where we're thinking about how what does data science on an academic campus look like. And one of the things we've gelled around is this idea of open access, of reproducibility, of publishing code, of doing research on GitHub or Bitbucket or those other tools that make the research available out there. And I'm pretty optimistic about that because there seems to be a good head of steam developing behind these ideas.
Interesting. Well, thanks again for coming on the show, and I really enjoyed this conversation.
Yeah, this was fun. Thanks.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.
Wow.